Hello? All right, well, let's get started with example 2. Example 2 says solve two-step equations that contain fractions both ways. Okay, so we're going to solve each of these fractions two different ways. So the first way we're going to solve it is by keeping the fractions. And then the second way we're going to solve it is by getting rid of the fractions. Okay, so each problem we're going to solve two different ways, and then we're going to make sure that we always check our answer at the end. So for this first one, we're going to go ahead and keep the fractions, okay? So we're trying to figure out what Q is, right? And so this Q is being divided by 15, and then there's this negative 1/5 out on the outside. So we're going to get rid of that first using the inverse operation, which would be just to add 1/5 to both sides, like so. Those cancel. We're left with Q over 15 equals, since these have a common denominator, that's really super nice. So we just add the numbers on top. 3 plus 1 is 4, and then keep that common denominator of 5. And then we are trying to get Q by itself. Right now it's being divided by 15, so we're going to do the inverse operation of division, which would be multiplication. We're going to multiply both sides by 15. What happens are these 15s cancel out. I'm going to go ahead and make this 15 over 1, which is the same thing as 15. And then we're going to multiply these fractions. Remember, you look to cross cancel first and then multiply across. So let's try to cross cancel. There's nothing we can do with the 1 and the 4. So let's see, are there any common factors between the 5 and the 15? And yes, 5. 5 goes into 5 one time. 5 goes into 15 3 times. And then we just multiply across. So over here we have Q equals 4 times 3, which is 12. Over 1 times 1, which is just 1. 12 over 1 is the same thing as just 12. So there's our answer. Q equals 12. Okay? Now we're going to solve this the second way, which means we're going to get rid of the fractions. Now, to get rid of the fractions, what you have to do is you have to find what would be the common denominator between 15 and 5. So all of the numbers that are on the bottom, those are the denominators. So we have a 5, and a 15. So basically, if we want to get all of the same number, it would be if we count by 5s and we count by 15s, like what's the first number that they all have in common? And if you count by 5s, 5, 10, 15, if you count by 15, 15, 30, the first number that they all have in common is 15. So what we're going to do is we're going to multiply both of the sides of the equation by 15. And I want you to do this exactly how I'm doing it. So this is how you're going to do it in your notes. Okay? So here, what we need to do is we need to multiply both things by 15. So I'm just going to write that out. 15 times Q over 15 minus 15 times 1/5 equals, and see, it's nice to have the equal signs lined up, 3/5 times 15. Okay, so I want to see this step where you multiply both equations by 15, both sides of the equation by 15. And then I want to see you actually distribute that out. 15 times this one, 15 times this one, and 15 times this one over here, right there. And then show your work right here, 15 times 3/5. All right, now we just have a whole bunch of little multiplication fractions. Remember, cross cancel, multiply across, cross cancel, multiply across, cross cancel, multiply across. All right. So here, let's look to cross cancel. 15 is a common factor. It goes into both 15 one time. Then we multiply across. We end up with Q. All right. Minus, let's go, we're looking at this, 15 times 1/5. Cross cancel, right? What's the common factor between 15 and 5? 5. 5 goes into 5 one time. 5 goes into 15 3 times. And then we multiply across. 3 times 1 is 3. 1 times 1 is just 1, so 3 over 1 is the same thing as 3, equals, and then here we go, cross cancel, multiply across. We have fractions, multiplying fractions again. So can't do anything with the 1 and the 3, but there is a common factor between 5 and 15, it's 5. 5 goes into 5 one time, 5 goes into 15 3 times, and then we multiply across. 3 times 3 is 9, and then 1 times 1 is just 1. 9 over 1 is the same thing as 9. So boom, there we have it. We got rid of all the fractions. So we're trying to figure out what Q is, and we just do the inverse operation of subtraction, which would be addition. We're adding 3 to both sides, and we end up with Q equals 12. So we got the same answer doing it two different ways, so that's exactly what we want. But now we're going to check the answer, and remember, we're going to write that original equation first. So I'm just going to kind of give myself some room here. I'm going to write that original equation, q over 15 minus 1/5 equals 3/5. Okay, and I'm going to substitute that 12 in for 15. All right, like that. And then I am trying to, 3/5, that's already simplified, so I'm just going to leave that. But I have to do this problem, so I'm subtracting, and I have two different denominators, so I need to get the same denominator. So the common denominator between 15 and 5 would be 15. So this is already 15, so we're good. I need to multiply this 5 by 3. 5 times 3 is 15. Whatever you do to the bottom, you have to do to the top. And you can do that because 3 divided by 3 is 1, and you can times anything by 1, and you get the same number. It just may look a little different. So this number we're about to get, it's the same thing as 1/5. So 3 times 1 is 3 over 3 times 15. 3 times 5 is 15. So 3/15 is the same thing as 1/5. It just looks different, but they are equivalent. They're the same. All right. So we have this, and now that we have a common denominator, we just subtract these numbers on top. So 12 minus 3 is 9. So we end up with 9/15 equals 3/5. And those aren't the same, but we can reduce this 9/15 because there's a common factor between 9 and 15. What is it? What goes into 9, which also goes into 15? 3. If you said 3, you're right. 3 goes into 9 3 times, and 3 goes into 15 5 times. So there we have it. We have our 3/5 equaling 3/5, which is a true statement, which means our solution, Q equals 12, is the solution to the original equation. All right, cool. So that was a lot when we keep the fractions and also getting rid of the fractions. So we're going to practice this a couple times because I want you to get used to this. And so, yeah, so let's try problem B. All right, so we're trying to get x by itself, right? So this first way, we're going to keep the fractions. And I just want you to know on all of your homework problems that include fractions, I want you to solve it both ways like this. Okay, so you're going to keep the fractions one way, and then you're going to get rid of the fractions. You're going to solve it again by practicing getting rid of the fractions, and then you're going to check your answer. So for every problem like this, we're going to do it both ways and then check. Okay, so let's try this here. So the first way is keeping the fractions. So we're trying to get this x by itself, right? So this is right now, it's 2 times x divided by 5, or you can think about it as 2/5 times x. They both mean the same thing. But there's this number on the outside that we're going to get rid of first. So to do that, we're going to add 1/2 to both sides. Okay. So we end up with, those cancel out, and we end up with 2x over 5 equals 5 plus 1/2 is just really the same thing as 5 and 1/2, right? And now I want to get this x by itself. And remember, whenever there's a fraction multiplied by a variable, we just multiply by the inverse, which would be 5 over 2 to both sides. And then the 5's cancel out and become 1, 1, and the 2's cancel out and become 1, 1, and 1 times all that is just x. So now x is by itself, which is exactly what we want. Perfect. So now we have a mixed number multiplied by a fraction, an improper fraction at that. So in order to multiply these fractions, we have to change this to an improper fraction as well. And remember, you do that by going 2 times 5, which is 10, plus 1, which is 11. So 2 times 5, 10 plus 1 is 11, and that's all over 2. And we're multiplying that by 5 over 2. So then we would just look to multiplying fractions, cross cancel, right? Is there anything we can cross cancel there with 11 and 2? There's no common factors, and no common factors there, so then we just multiply across. So we get x equals 11 times 5 is 55 over 2 times 2 is 4. 55 over 4. And that's an improper fraction, and whenever you're doing algebra, you just leave it like that as an improper fraction. You wouldn't change it to a mixed number. That is your answer. All right, so let's do it the second way and get rid of these fractions, okay? So to get rid of the fractions, what we have to do is we have to figure out, well, what would that common denominator be? So we have a 5, a 2, and this is 5 over 1, right? So basically, if we count by 2s, 2, 4, 6, 8, 10, and we count by 5s, 5, 10, what's the number that they both have in common? The answer is 10. So what we're going to do is we're going to multiply this side of the equation by 10, and we're also going to multiply this side of the equation by 10. Okay? So you're going to show that. That's going to be your first step. Your second step is going to be the distributive property, showing 10 times 2x over 5 minus, and then 10 times 1/2. So this is how I want you to show your work. And then, 5 times 10. Okay, let's go ahead and do this multiplication of the fractions. 10 is the same thing as 10 over 1. So remember, we always look to cross cancel first and then multiply across. So are there any common factors there? Nope, but what about here? Yep, 5. 5 goes into 5 one time. 5 goes into 10 2 times. And then we multiply across. 2 times 2x is just 4x. And then 1 times 1 is just 1. And 4x over 1 is the same thing as 4x. So we're just going to leave it like that. And then we're going to subtract and come over here. And remember, we're looking to cross cancel first. So there's nothing we can do with those 1s. But what about 2 and 10? Do they have a common factor? Yes, they do. 2 goes into both of those. 2 goes into 2 one time. 2 goes into 10 5 times. And then we multiply across. 5 times 1 is 5. And then 1 times 1 is 1. 5 over 1 is the same thing as 5. Equals 5 times 10, which is 50. Perfect. So now we got rid of the fractions, right? We're just going to isolate x and get x by itself. So we're going to add 5 to both sides. All right. And those cancel. We end up with 4x equals 55. And then we just want to get x by itself. It's being multiplied by 4, so we have to do the inverse operation of multiplication, which would be division. Division of 4 to both sides, and we end up with x equals 55 over 4. Perfect. That's our answer, and we got the same thing. Awesome. So now we're going to check our answer. So we're going to go ahead and write that original equation. So I'm going to write 2x over 5 minus 1/2 equals 5. Okay, and I'm going to write it kind of small because I think I'm actually going to need a little bit more room than this to do my check. So I'm going to substitute this 55 over 4 in for x here. And so it's going to look like this. 2 times 55 over 4 divided by 5. So now I have a complex fraction. Minus 1/2. It's not a big deal. We just need to do one step at a time, right? So what we're going to do is we're going to do this part right here, which is really just multiplying by fractions again. So we always look to cross cancel. Can't do anything with the 1 and the 55, but we can cancel out a common factor here between 2 and 4. What's the common factor? Yes, it's 2. 2 goes into 2 one time. 2 goes into 4 2 times. So then what we end up with when we multiply across, 1 times 55 is 55. 1 times 2 is 2, so it's 55 over 2 divided by 5 minus 1/2 equals 5. All right. So I have this complex fraction here, and whenever I have a complex fraction here and I get to this point, I just like to go old school with it. And so I'm going to go 55 over 2 divided by 5. So I'm going to rewrite it like this, 55 over 2 divided by 5, and then rewrite all this other stuff, minus 1/2 equals 5. And then whenever you have you're dividing by a fraction, 5 over 1, which is the same thing as 5, that is the same thing as multiplying by the reciprocal, which would be 1/5, right? 5 over 1 and 1/5, they are reciprocals of each other. Minus 1/2 equals 5. Okay, so now we have this, we're multiplying by fractions again. I'm telling you, we're going to do this all the time. So we look to cross cancel and then we multiply across. So we can't cancel out anything here, but what about here? 55 and 5, are there any common factors? The answer is yes, 5. 5 goes into 5 one time, 5 goes into 55 11 times, and then we just multiply across. And I'm kind of running out of room over here. So what I'm going to do is I'm going to kind of just move my way up here. Okay, and keep the party going. So, what do I have? I multiply across. 11 times 1 is 11 over 2 times 1 is just 2 minus 1/2 equals 5. Okay. This is nice because now we have a common denominator of 2. So all we need to do is subtract these numbers on top. 11 minus 1 is 10 over 2 equals 5. And then we just need to simplify this. 10 divided by 2 is 5. So this is a true statement, which means our answer, x equals 55 over 4, is the solution to our original equation right over here. Man, that was a lot of work. Okay, let's go ahead and practice this. We're going to practice this 2 more times because this process is kind of complicated, and so we just need to practice. Whenever you have a more of a complicated process, the more you practice it, the easier it gets. All right. So we're going to go. Let's try C. So the first way we're going to solve this, remember, is keeping the fractions as they are. So for this problem, we're trying to figure out what n is. Okay? So that means we need to get n by itself. Right now it's being multiplied by 1/5. And so we're going to keep that how it is, but we're going to get rid of this bit on the outside, which is subtracting by 1/3. We're going to do the inverse operation, which would be adding 1/3 to both sides. Okay, those cancel, and we are left with 1/5 n equals, okay, we have a common denominator here, which is really nice, so we just go 8 plus 1, which is 9, and keep that common denominator of 3. All right. Then we're trying to get n by itself. Right now it is being multiplied by 1/5, and whenever there's a fraction, we always try to multiply by the reciprocal, 5/1. 5/1 is the same thing. Oh, we're just going to do that to both sides, 5/1. So those 5s end up canceling out, and then we have 1 times 1, which is just n, equals, and then over here we want to look to, we're multiplying fractions, look to cross cancel, and then multiply across. Is there any common factors between 3 and 5? No, there's not. What about 1 and 9? Oh, there's a 1. You can't really do anything with that. That can't get any more simpler than a 1, right? So you always know when you see a 1, you can't cancel anything out. So we're just going to multiply across. 9 times 5 is 45, and 3 times 1 is 3. So I want to know, hey, is 45 divisible by 3? Well, an easy way to determine whether 45 is divisible by 3 is you take the digits 4 and 5 and you add them together. 4 plus 5 is 9, and 9 is divisible by 3. That means the whole number 45 is divisible by 3. So I'm going to go over here and I'm just going to do a little long division. 45 divided by 3. 3 goes into 4 one time. 1 times 3 is 3, and 4 minus 3 is 1, and then I'm going to drop this 5 down. And then I end up with 3. How many times does 3 go into 15? It goes in 5 times. 5 times 3 is 15. There's no remainder. There's nothing else to drop down. So boom, there's my answer. N equals 15. All right, cool. So now we're going to come over here and we're going to do it the second way, which remember is getting rid of the fractions. So to get rid of the fractions, what we're going to do is we're going to look at the numbers on the bottom. So we have 5 and 3. So basically, if we count by 3s and we count by 5s, what's the first number that they both have in common, right? And that would be 15. So that means we're going to multiply this side of the equation by 15 and this side of the equation, because whenever you're doing equations, you have to keep things equal. So whatever you do to this side, you have to do to this side as well. Okay. So this is what the first step is going to look like. Then you're going to multiply that 15 here and here. So we're going to write that down. 15 times 1/5 n minus 15 times 1/3 equals, and then multiply it here, 8/3 times 15. Perfect. Then we are just going to do these little multiplication fraction problems here. So look to cross cancel, right? So what goes into 15 and 5? 5. 5 goes in there 1 time. 5 goes in there 3 times. And then we multiply across. 3 times 1 is 3. And then 1 times 1 is just 1. So we end up with 3n minus, let's go over here. Can't do anything with the 1 and 1s. What about the 3 and 15? Is there a common factor there? Yes, 3. 3 goes in there 1 time, 3 goes into 15 5 times, and then we multiply across. 5 times 1 is 5. 1 times 1 is 1. 5 over 1 is the same thing as 5. Equals, and then we look here to cross cancel, right? Can't do anything with the 1 and 8. What about the 3 and 15? Yeah, they have a common factor of 3. 3 goes into 3 1 time, 3 goes into 15 5 times, and then we multiply across. 8 times 5 is 40, and 1 times 1 is just 1. 40 over 1 is the same thing as 40. So there we have it. We have an equation that doesn't have any fractions. So we were successful. We got rid of all the fractions. Now we got to figure out what n is, right? So we're going to keep this and get rid of this bit on the outside. So we're going to do the inverse operation of subtraction, which would be addition of 5 to both sides. That cancels, and we're left with 3n equals 40 plus 5, which is 45. And then we want to get n by itself, and it's 3 times n, so the inverse operation of multiplication would be division of 3 to both sides. 3 divided by 3 is 1. 1 times n is just n. Equals 45 divided by 3, and we did that over here. 45 divided by 3 is 15. Boom, got the same answer. That's awesome. Okay, so now we're just going to check our answer. So we're going to go ahead and write that original equation. 1/5 n minus 1/3 equals 8/3. And we substitute that 15 in for n. So we have 1/5 times 15 minus 1/3 equals 8/3. All right. So we have a little multiplication fraction problem here. So we're going to make this 15 over 1, and then we're going to look to cross cancel. So here we go. Is there a common factor between 1 and 1? Nope. What about 5 and 15? Yep, 5 goes into both. 5 goes into 5 1 time, 5 goes into 15 3 times, and then we multiply across, right? 1 times 3 is 3, and then on the bottom, 1 times 1, 3 over 1, same thing as 3, right? Minus 1/3 equals 8/3. Okay, now I need to simplify this. So I'm actually going to make it 3 over 1 because I need to get a common denominator. So the common denominator between 1 and 3 would be 3, right? So this is already a 3, so we're good. We need to make this into a 3, and we do that by multiplying 1 by 3. 1 times 3 is 3. Whatever we do to the bottom, we have to do the top, because 3 divided by 3 is 1, and 1 times this is going to be the same thing. It's just going to be written in a different form. So 3 times 3 is 9 over 3 times 1 is 3. I rewrite this. See, 9 divided by 3, that's the same thing as 3. So it's just a different, they're equivalent, just a different way of writing it. All right, now we're just going to do this bit. We have a common denominator, which is great, which means we just do this little subtraction on top. 9 minus 1 is 8 over 3 equals 8/3. And this is a true statement, which means our solution is the solution to this original equation. Perfect, perfect. So I want you to try this one on your own. Okay, so here is my friend. This is the pause dragon. Okay, so the pause dragon reminds you that it's time to now pause your device. So I want you to work this out. Remember, this is the way that you keep the fractions. This is the way that you get rid of the fractions, and then you're going to check your answer, okay? So go ahead and pause your device. Work out the problems on your own. Make sure you write in pencil, because if you don't, if you make a mistake or something, then you want to be able to erase it. So write in pencil. So go get a good pencil. And when you get done, press play, and then listen to the full explanation. And then if there's anything that you did differently than I did, then make sure you erase it and then write down the correct way to do it. All right, we'll see you in a bit. All right, we are back. Let's go ahead and do problem D. So we are trying to figure out what U is. In this first way, remember, we're going to keep the fractions. So we have 3/4 times U plus 1/2 equals 7/8. So we're going to keep this, and we're going to get rid of this positive 1/2. Use the inverse operation, which would be subtracting 1/2 to both sides. Okay, that cancels. We're left with 3/4 u, right? And then these don't have a common denominator. So we are going to have to get a common denominator. The common denominator between 8 and 2, if you count by 2s and you count by 8s, the first number they both have in common is actually 8. So we don't need to do anything here, but for this one, we're going to have to multiply this by 4 to the bottom and the top to get that common denominator. So what we end up with is 7/8 minus 1 times 4 is 4. 2 times 4 is 8. Okay. And then we're going to go 3/4 u equals, since we have a common denominator, then we just subtract the numbers on top. 7 minus 4 is 3/8. Perfect. Now we're trying to get this u by itself, right? And so this u is being multiplied by a fraction. Do you remember what we do when we are, the variable is multiplied by a fraction? Yeah, we multiply by the reciprocal, which would be 4/3 to both sides, because what's really great is they just all cancel out and turn into 1. And then 1 times u is u, and now we have u by itself. Okay, now we have this fraction. Remember, multiplying by fractions, we look to cross-cancel first, and then we multiply across. Okay, so cross-canceling, we have a 3 and a 3, so that means 3 goes into both. 3 goes into 3 one time, 3 goes into 3 one time. And then we look here, what goes into both 4 and 8? The answer is 4. 4 goes into 4 one time, and 4 goes into 8 two times. And then we just multiply across. 1 times 1 is 1 over 2 times 1 is 2. And there we have our answer. U equals 1/2. All right, cool. Let's go over and try it the second way, which is getting rid of the fractions. So now, remember, you have to multiply this entire equation, both sides, by a number. And that number is, if you count by 2s, you count by 4s, and you count by 8s, what's the first number that they all have in common? So if you count by 2s, 2, 4, 6, 8. You count by 4s, 4, 8. And if you count by 8, well, just 8, 8, 16, whatever. But the first number they all three of these have in common is 8. So we're going to multiply this entire side by 8. So make sure on your paper that you wrote this step. This is what the first step should be. The second step is you actually multiply 8 to both of these things, and it looks like this. 8 times 3/4 u plus 8 times 1/2 equals 7/8 times 8. And this is just a process to get rid of all the fractions. So we have to do this little multiplication problem here. I'm going to make this 8/1, right? We're multiplying fractions, look to cross cancel. Is there a common factor between 4 and 8? Yes, 4. 4 goes into 4 one time, 4 goes into 8 two times, and then we multiply across. 2 times 3 is 6, 6u. And then 1 times 1 is just 1, so we can just leave it as 6u. Plus, let's look over here, 8/1, look to cross cancel. Is there a common factor between 8 and 2? Yes, 2. 2 goes into 2 one time, 2 goes into 8 four times, and we multiply across. 4 times 1 is 4. 1 times 1 is just 1. 4/1 is the same thing as 4. Equals, and then we make this little 1. So we're going to look to cross cancel. Is there a common factor between 8 and 8? Yeah, 8. 8 goes into 8 one time, 8 goes into 8 one time, and then we multiply across. 7 times 1 is just 7. 1 times 1 is just 1. So there we have our equation. This is our two-step equation that doesn't have any fractions. So we got rid of all the fractions. We're trying to get u, right? 6 times u, so we have to get rid of this bit on the outside first. So the inverse operation, when you're adding 4, would be subtracting 4 to both sides. So 7 minus 4 is 3. And we have u, we have 6 times u, so the inverse operation of multiplication would be division. We're going to divide by 6 to both sides. 6 divided by 6 is 1. 1 times u is just u. Equals 3/6. So we just need to really just reduce that fraction, right? Is there a number that goes into 3 and 6? A common factor? Yeah, 3. 3 goes into 3 one time, 3 goes into 6 two times, and we end up with 1/2, which is exactly the same answer that we got when we solved the problem keeping the fractions. So that's great. Now we're going to go over here and we're going to check our answer. So first, I'm always going to write that original equation down. So we have 3/4 u plus 1/2 equals 7/8. All right, and then we're going to substitute 1/2 in for u. So that's going to be 3/4 times 1/2 plus 1/2 equals 7/8. Okay, so first we're going to do this little multiplying fractions bit. So remember, we're going to look to cross cancel first and then multiply across. So is there anything we can cancel out with 3 and 2? No. What about 1 and 4? No. So we're just going to multiply across. 3 times 1 is 3 over 4 times 2 is 8 plus 1/2 equals 7/8. All right, so we have to simplify this side. We're adding fractions. They don't have the same denominator. This has an 8 and this has a 2. Remember, denominator is the number in the bottom of a fraction. So we have to get the same number. So when you count by 2s and you count by 8s, what's the first number they have in common? Well, it would be 8. So this is already an 8, so we're good. But we need to make this 2 and 8. So we make this an 8 by multiplying it by 4 to the bottom and the top. Okay? So we get 3/8 plus 1 times 4 is 4 over 2 times 4, which is 8. And then we just have a common denominator, so we add the numbers on top. 3 plus 4 is 7 over 8. And there we have it. We have the same number, 7/8 equals 7/8, which means we have a true statement, which means our answer, u equals 1/2, is the solution to our original equation right over here. So if you got that right, awesome job. If you didn't, I need you to erase and I need you to fix it so it looks exactly like this, okay? And remember, on your homework, we're going to do each of these fraction problems. We're going to do it where we keep the fractions, and then we're going to do it where we get rid of the fractions, and then we're going to check our answer. So yeah, that's what we expect. That's what I expect in your homework. All right, we'll be back in a little bit for example 3.